Hello everyone, hope you all are safe and sound. Welcome to this video in my channel Coding Tiger. Today we are going to look at a straightforward yet engaging topic. Why is computer processor speed expressed in Hertz? You may be familiar with a processor, which is the most significant part of a computer. All activities that can be referred to as computing in a computer occur here. In other words, when we write a computer program, the processor is where the instructions are executed. How do we usually define the speed of such a component? Which is how many instructions it can carry out in a second. For example, in 1 second, if it can execute 10 million instructions, then its speed is said to be 10 million instructions per second. Its unit should be million instructions per second, or MIPS or MIPS for short. Whereas, even if there is such a unit exists, what we generally hear nowadays is 3.3 GHz or 4 GHz or such. We are looking at where this gigahertz comes from. Before that, let's talk about what Hertz is. Hertz is the unit of frequency. What is frequency? Frequency is the number of cycles per second in a wave. That is, the magnitude of a wave goes from 0 to a maximum and returns to 0 and then goes to a minimum and then returns back to 0. A hertz is how many times this happens in 1 second. If 1 cycle in a second, it is 1 hertz. And if 2 cycles, then 2 hertz and so on. What is gigahertz? The term giga represents 10 raised to 9. Now 3.3 gigahertz means 3.3 multiplied by 10 raised to 9 hertz. That means 3.3 multiplied by 10 raised to 9 waves per second. So now we see how hertz, the unit of frequency, came as the speed of the processor. As we said earlier, processor is a component used inside a computer, which is an electronic device. To be more specific, it is a digital electronic component. We need to know what is going on inside. For example, if an instruction of a program is to add two numbers and save the sum in memory, let's see what happens here. For that, the first number has to be fetched from the memory into the processor. After that, the second number should be reached. Then add the two numbers together and save the sum back into the memory. Now you can see that multiple operations are performed as part of an instruction. Synchronizing these operations is essential for a smooth execution. Now, if the second number is fetched before the first number, or if the addition operation is done before these two numbers are reached, our instructions will not execute properly. That's why synchronization is essential. We now look at how to achieve this synchronization. It is done by feeding a digital signal to the processor. The example we are going to see here is from a very high level. The actual operation is more complicated than this. Let's consider it in this way. The processor takes the first number on the first wave of the aforementioned signal, takes the next number on the second wave, adds them together on the third signal, and saves the sum to the memory on the fourth signal. In this way, if the operations are controlled with a signal, there will be no synchronization issues that we mentioned earlier. The frequency of this signal we used here is what we say in gigahertz. As each operation with an instruction is regulated by a signal, the speed at which an instruction is executed depends on the frequency of the signal. That is, the higher the frequency at which the operations can be synchronized, the faster the execution will take place. Then comes another question. Is it not possible to increase its speed by giving a signal at a very high frequency? But unfortunately it won't happen. Why? The processor should be able to work according to this given frequency. It has a maximum speed at which it can work. That's a frequency limit. It cannot work at a higher speed or higher frequency. And we don't even operate the processor at this maximum limit. Because if it runs at this maximum capacity, its temperature will be too high to cool and eventually the processor may burn out. That's why only a safe frequency is given and operated. Now, if we look at a trend in the past, the manufacturers followed a strategy of rapidly increasing this operating frequency for increasing the speed of the processor. But when the temperature problem outgrew the ability to regulate with fans and other such cooling methods, they made the choice to progressively discontinue it and look for alternative methods of speeding up. Let's discuss that in a different video. The signal used to synchronize the operations of the processor is called a clock signal. The frequency of this clock signal is what we refer as gigahertz to represent the speed of a processor. I sincerely hope everyone enjoys and grasps the video. This is my first one and I'll try to make the following ones even better if you give your insightful comments and suggestions below. Thank you so much for watching. Bye for now.